Hello, this is my Lab 5 submission. My name is Gabriel Rueda, and today I'll be exploring the concepts of sound and the physics behind how sound works. So fundamentally, sound is a wave. It's classified as a longitudinal wave and requires a medium to pass through. Typically, it's air, water, even solid objects. The properties of this sound wave include the amplitude, which is directly proportional to the maximum pressure difference um, of the air from an area of high concentration to an area of low concentration of air or pressure. The frequency, which is the pitch, and the speed of the sound. So the speed of sound is a variable quantity depending on both the medium and the factors of the medium. The relationship between the frequency, wavelength, and speed is demonstrated by this formula right here. Sound as a wave carries energy, which is quantified in its intensity, which is a function of energy, and it's directly proportional to the square of the amplitude. The lab seeks to explore the properties of air density, which is modeled by mass, because the density is mass over volume, and volume is constant in every glowscript run, and so it can just be modeled through mass of each particle. And the particles demonstrate air and how air particles move based on vibration. And this is what the glowscript code ends up running. The parameters in code include a rectangle oscillating back and forth, moving the particles to simulate air and model sound, which is what I just showed. And the parameters include amplitude at 0.7, frequency is the variable, the independent variable that will change, and then particle mass is also variable. It just kind of demonstrates how both particle mass and frequency will affect wavelength. So these are some of the results, just screenshots of the glowscript code running. As you can see, these two have a 0.001 mass for the particles, and these all have variable frequencies, as you can see, 4 and 4. And then for this one, it's 10, and for this one, it's 2. And so you can see that there's a lot of importance that the mass of the particles has, and also the frequency. And as you can see, this wavelength is quantified by the number of columns between each crest, essentially, each area of high density. So the results show that the frequency and mass will affect the wavelength, which the frequency directly correlates with the wavelength, and mass is also inversely proportional to wavelength as the inertia is greater for more dense air. This lab models how sound waves travel through particles and how different factors change wave dynamics. The amplitude, density, frequency, wavelength, and energy are all related, and this shows how they are. Sound is a fundamental to so much in the world, and anything that vibrates creates sound in some way. Speakers use this principle to recreate sound, and anything that makes a sound vibrates. Even impact is a sound wave. It's a really short one because it causes vibration in the components of the impact to make sound waves. Musicians will utilize a lot of these concepts, especially when designing an instrument or some kind of synthesizer, to either analog or digitally recreate sound. And there's more concepts that come to sound that are beyond the scope of this presentation, including harmonic sound, or the way it passes through different mediums, different types of mediums, and so forth. And that is topic for future discussion and research. So anyway, thank you for listening to my presentation, and go Jackets.